Students, today's class is about basics of mechanism. So first we see about the simple mechanisms. The simple mechanism. So first what is my machine? So machine is a device which receive energy and transform it some useful works. Some examples are IC engine, fan, lathe are the machines. It consists of number of bodies. So next, the machines consist of so much of links. One is the kinematic links or element. Each part of a machine which moves relative to some other part is known as kinematic link. The links consist of three types of links. One is binary link, ternary link, and quaternary link. So binary link consists of two nodes, and ternary link consists of three nodes, and then quaternary link consists of four nodes. So next, reciprocating steam engine. So reciprocating steam engine working under the mechanism of a Sladecker mechanism. It has a crank link, and then connecting rod, and then piston. Piston and cylinder is a fixed link. The crank link is a first link one is the piston or piston rod crank cross constitute, and then second link to connecting rod with a small big and small end, and then link 3 crank is a rotating link, and then link 4 is the cylinder or engine frame or main bearing. So next we see about the resistant body. So resistant body, a body is said to be resistance if the capable of transmitting the required forces with negligible deformation. It has some characteristics. It should have a relative motion, and then it must be a resistant body. So next the types of links. So types of links consists of three types. One is a rigid link, flexible link, and fluid link. So rigid link means does not undergo any deformation. Example: connecting rod, crank, example, etc. So next flexible link. So flexible consists of it is partially deformed in a matter does not affect any transmission of motion. Example: belt ropes. So belt ropes are transmitting some belt ropes transmitting one shaft transmitting speed from one shaft to another shaft. So it does not affect any transmission of motion. So next fluid link. So in the fluid link is for example hydraulic presses, jacks, brakes are working under the fluid. Next one is structure. So structure is a resistant body. A number of resistant body. It has no relative motion between them. Example: bridges, roofs, trusses, machine frames, like that. So next, what is the difference between machine and structure? So machine have move the machine move relative to one another, and the structure does not move any relative motion. It doesn't machine transforms some energy into useful works. Structure has no energy transformed into useful. It withload the withstand the load. Next one is kinematic pair. The kinematic pair consists of two links. Two links are element of a machine which contact with each other is said to be a pair. If relative motion between the completely successfully constrained, the pair is known as kinematic pair. This is the pair. So is the one link and then another link. This is considered one pair. It has three types of motions. One is a type of completely constrained motion. The completely constrained motion means the degrees of freedom is 1. If you have a square hole and a square bar is inserted into the square hole, it has only it allows only in it allows the shaft into the one direction, and then another in this another diagram the shaft with the collar, the shaft does not move forward and backward direction. It possible move only in the rotating motion. That is a completely constrained motion. So in the engine, the piston is a completely constrained motion. So incompletely constrained motion means it allows degrees of freedom is 2. It allows to move in more than one direction. So in a instead of square hole, it has a round hole. The round shaft is inserted in the round hole. The shaft is allowed to allow from forward to backward direction, and then it also possible to rotating. So the two type of motion is the rotating and sliding. This is also another example. The next, successfully constrained motion. Successfully constrained motion means if a shaft is inserted into the footstep bearing, the shaft with some type of load, it cannot be allowed to rotate. So the shaft only upward and downward movement is there. So there is a successfully constrained motion. So when the motion between the two elements forming a pair such that the constrained motion is not completely by itself by applying some load to the shaft, it can, that is successfully constrained motion. The next, the classification of kinematic pairs. So, based on the different types of contacts, so according to the types of the relative motion, first the sliding pair. So, sliding pair is, for the example, the piston and cylinder is the sliding pair. The turning pair. So, the turning pair means the shaft and the collar are both ends fitted into the circular hole. The shaft is allowed to rotate, and the shaft is also move forward and backward direction. So, it is a turning pair. The rolling pair means the two elements are connected in such a way that the rolls over the another fixed link. That is the rolling pair. And the screw pair means, example, the screw nut bolt and nut are consists of a screw threads. So the instead of screw threads, so another example is the lead screw. So lead screw in the lathe. So garage moves over the lead screw with the screwing pair. And in the spherical pair, the mirror is mirror fixed in the car is considered a spherical shape. A spherical pair, it is in a spherical shape, so rotate in all over the directions. According to the type of contact, the lower pair, that is surface contact, the two elements is have a pair have a surface contact with relative motion take place. The surface is one element slide over the another element is a lower pair. Example, uh, uh, garage move in a guideway of the lathe. And the higher pair is the two elements pair have a contact with a line or point contact. That is a higher pair. For example, cam and follower is a cam and follower and gear are the higher pair. The example for cam and follower, there is a higher pair is a line contact, and then gear in mesh is also a line contact. According to the type of closure, some uh, some pairs are closed by self-closed due to the gravity. So when the two elements of the pair are connected together mechanically in such a way that only required to relative motion occurs, it is called as self-closed pairs. Lower pair is also known as self-closed pair. The force closed pairs when apply is not connected mechanically, but there's some contact in action by applying some external force. So the pair is said to be a force close with the cam and follower. So the follower is fixed with the spring, means the follower is attached forcefully by some apply external spring force. Due to the spring force, the follower contact with the cam. So it is known as a force close pair. Next, the kinematic chain. So when the kinematic pairs are coupled in such a way that the last link is connected to the first link, it transmits some definite motion, is known as kinematic chain. This is the example for kinematic chain. So is a in this diagram, so L is the length of the link, J is the number of joints, so L is the number of link, J is the number of joints, and P is the number of pairs. So the condition to form a kinematic chain, so the L is the number of link, P is the number of pairs and number of joints. So it forms the equation the L equal to 2P minus 4, and then J equal to 3 by 2 L minus 2. So if LHS and RHS is LHS is greater than the RHS, means it is a locked chain. Both are same, means the constrained kinematic chain. LHS and LHS is less than the RHS, means there is unconstrained chain. So from the above equation, we have to determine the number of degrees of freedom and then what type of chain is available or not. Next, the types of joints in the chain. One is the binary joint. So binary joint containing the two links are connected in a same connection, means that is binary joint. So ternary joint means the three links are connected in a same connection, means ternary joint, and then four links connected in a joint is known as a quaternary joint. From this diagram, we calculate the what type of joints, how many joints are there, how many binary joints, and how many ternary joints, and then how many quaternary joints are there in the diagram. So next is the binary link and ternary link, and then quaternary link. So binary link consists of 2 nodes, and then ternary link consists of 3 nodes, and then quaternary link consists of 4 nodes. Next, degrees of freedom. So degrees of freedom is number of input parameters which is must be independently controlled in order to bring the mechanism into useful engineering purpose. So for the finding of n is the number of degrees of freedom. So n equal to 3 L minus 1 minus 2J and H. So L is the number of links, and 2J is the number of joints, and H is the number of higher pairs. The Kushbach criterion, the higher pair is 0. If any higher pair is not available there, so the higher pair is equal to 0. So the mechanism, so one of the links of the kinematic chain is fixed, means there is the mechanism. It is known as mechanism. So it transmits some definite motions. Example, indicators, type rating, other mechanisms. The mechanisms with the 4 links is known as simple mechanisms, and more than 4 links is known as combined mechanisms. When the mechanism is required to transmit some power or do some particular type of work, is known as becoming a machine. So mechanism, difference between the mechanism and machine means the mechanism is the assemblage of links and transmits some body or modify the motions, and machine is the assemblage of transmit motion and energy. The mechanism is skeleton outline of the link. The machine is consists of one or more mechanisms and transmits some available energy. So examples: drafter, typewriter, and clocks, spring toys are the examples for mechanisms, and machines. The examples are sewing machine, shaper, planer, and ice engines, etc. Is a Kubler criterion. So Kubler criterion applies the mechanism to only the single degrees of freedom joints. Overall the mobility of the mechanism is unity. So so degrees of freedom is 1 means, so n equal to 1. So apply the equation in the Kushbach criterion equation. So, and then higher pair equal to 0. So apply the n equal to 1 and h equal to 0 in the Kushbach equation. We get finally the 3l minus 2j minus 4 equal to 0. This is the Kubler's criterion. So the degrees of freedom value is equal to 1 means that is the Kubler criterion equations. So finally we got 3l minus 2j minus 4. L is the number of links and j is the number of joints for the planar mechanism.